In the vast emptiness of space, nothing should feel alive. Stars are born, burn, and die according to physics so rigid it feels mechanical. Galaxies collide without emotion. Gravity pulls without intention. But astronomers have discovered something that breaks this expectation completely. A massive cluster of stars that doesn't move randomly, doesn't drift apart, doesn't behave like debris. Instead, it moves together, like a living organism. At first, scientists thought it was a data error. Thousands of stars, spread across dozens of light years, were seen accelerating and slowing down in unison. Entire regions compressed while others stretched outward, not explosively, but rhythmically, almost like breathing. This discovery came from the European Space Agency's Gaia telescope, which maps star positions with extreme precision. When astronomers plotted the motion data over time, something unsettling appeared. Patterns, waves of movement rippling through the cluster, rotational flows forming and dissolving, structures bending and realigning as if responding to invisible signals. Star clusters aren't supposed to do this. Normally, once stars are born from the same gas cloud, they slowly drift apart. Galactic gravity pulls them in different directions. Dark matter disrupts their paths. Within a few million years, the cluster dissolves. But this one didn't. Instead of falling apart, it behaved as a single system. When one region accelerated, neighboring regions adjusted. When part of the cluster stretched, another part contracted, maintaining balance. This is the moment scientists began using a disturbing phrase: collective motion. In biology, collective motion appears in flocks of birds, schools of fish, and even living cells. No single unit controls the system, yet the whole structure responds as one. Seeing this behavior in stars was never expected. Even more unsettling was the timing. The motion wasn't constant, it came in pulses. Every few million years, the cluster shifted its internal structure like a slow cosmic heartbeat. These pulses were too regular to be random, yet too complex to be explained by simple gravity models. Some researchers propose that unseen clouds of dark matter might be flowing through the cluster, pulling stars in coordinated patterns. Others suggested shock waves from ancient supernova explosions. But none of the simulations fully matched the observations. The cluster didn't just react, it adapted. When gravitational stress increased in one region, the internal motion redistributed energy elsewhere, preventing collapse. When tidal forces from the galaxy tried to stretch it apart, internal rotations tightened its structure. This is something only living systems are known to do. Of course, no one is claiming the cluster is alive in the biological sense. There is no metabolism, no DNA, no consciousness. But the behavior raises an uncomfortable question. If life is defined by self-organization, adaptation, and collective response to the environment, where exactly do we draw the line? The universe has always challenged our definitions. Stars were once thought to be eternal. Galaxies were once thought static. Even planets were once believed rare. Every time we assumed nature had limits, the cosmos proved us wrong. And now, we are forced to ask, could complexity itself emerge on cosmic scales? Some physicists believe this cluster represents a new category of structure, systems governed by gravity, but behaving like fluid networks rather than rigid objects. Others speculate something even stranger, that we are seeing the early stages of a phenomenon never observed before, a transition from chaos to order on a galactic level, a kind of cosmic self-organization. If similar clusters exist elsewhere, they could change how we understand galaxy formation, dark matter distribution, and even the long-term evolution of the universe itself. Because if stars can move together like cells, then galaxies may not be simple collections of matter, they may be systems, and systems can evolve. For now, the cluster remains under constant observation. Each new data release reveals movements that defy prediction. Models are updated, simulations rewritten, assumptions discarded. And still, the pattern remains. Slow, deliberate, alive-looking. Some astronomers have quietly admitted something unsettling. When you watch the data long enough, when you see the stars shift, realign, and respond, it stops feeling like physics and starts feeling like behavior. In a universe that already humbles us at every scale, this discovery delivers a final reminder. We may understand the laws of nature, but we do not yet understand what nature is capable of becoming. And somewhere, deep in the dark between galaxies, a cluster of stars continues to move, not randomly, but together.